So the integer value before user input is 34. Now let's input a value that's 98. So integer value after user input is 98. So what happened behind the scenes? Let's actually make this a little more interesting. Printf type an integer value. This will help the user to understand what sort of value will the program take from him. So this will be okay. I'm running the old program. Okay, right now it tells me that the previous value was 34, or the current value, right, that's being or that is stored inside the uh, integer variable is 34, or currently the machine has the value of 34. Now it's telling the user that you must type in an integer value. So let's type in 23, or something like 120 or 120, and then press enter. Now it's telling me that integer value after user input is 120, which means that our variable after taking the user input now contains the value of 120 instead of 34. So how's that working? So the first thing is that I think I don't have to explain the printf functions. As you know right now, it's actually printing out the previous value from by retrieving the value from the integer variable I, and then the next printf function is prompting or asking the user to type in an integer value. The interesting part comes in scanf function. So just like printf function, this I, or this variable I, is being plugged into using this format specifier specifically designed for integers. But this address operator is causing to happen, or it's changing something behind the scenes. So this scanf function is actually taking the user input through this format specifier. So we also come to learn that this format specifier has twofold, or it has two phases. One phase is used to display some sort of value, just like this part, where we're just displaying the retrieved value from this integer variable. But this format specifier inside this scanf function is actually taking the value from the user, and then it's taking or storing that inside this integer variable called I. So there are two-way interactions that are going on. So the first interaction is that the value is being retrieved from this variable I, and then it's being connected to this format specifier for the integer. But in this case, what happens, this scanf function takes the user input, or it takes the user input as an integer and sends that to the integer variable of I. So it's something, the opposite thing is actually occurring when we try to use this scanf function. But this address operator does something more than what we can see. Behind the scenes, when we try to dissect the RAM looks something like this. So this is the continuation. So if you have 4 GB of RAM, you might have 4 billions of space. Let's say we have got 4 bytes of space in here, because we are now dealing with integer variables. So integer variables are stored inside this 4 byte of space. But this 4 byte of space has a name of I, which was defined by us, or which was defined by the programmer. But inside the computer, it's something different. Why? Because each of those blocks, each of these uh, blocks have their own addresses. Their addresses might be something like this. Um, it might be something like 1349, then 13 50, It might be again 13051, then the last one might have an address of 13052. So the address actually works something like your house's address. Your house can have a name. When you build your house, you might name it, you might actually, when you look at the apartments, so apartments have their own name assigned by the developer or the real estate agent or the firm that built that apartment. But that apartment has a specified number that was assigned by the city planners or by the government. So your house can be situated in a place like this. So if we consider this to be a road, then these are some blocks. I know my drawing is quite horrible, but I think it will work. So this is one block. This block has an address of 1. This is another block. This can have an address of 2. This is another block. So this can have an address of 3. This is 4. This is 5. This is 6. So each of these blocks have been assigned to a house owner or to a real estate agent who has built an apartment. There can be a duplex house in here, there can be an apartment here, there can be a one-story house in here, there can be a shop in here. So these numbers were actually assigned by the city planners or by the government. But if this plot belongs to you, the plot with the address 1 belongs to you, you can build your house and you can name your house as something like, I don't know, um, let me use my name. So my house has a name that was assigned by me. So similarly, the variable name has been assigned by the programmer. But that house has also something called an address. Now this address is unique, but the name is not unique. This plot can also have a house, or this plot can also have a house with a similar name, Nafis, just like this. There can be a lot of Nafises around that neighborhood. So how do you identify? So a relative or a visitor wants to visit my house, but he knows that there are two houses with the same name. But how does he identify which house is mine? I tell him that my plot number or my house number is 1. So that house number is actually unique. Similarly, behind the scenes inside the RAM, the 4 bytes of space has a name that was assigned by me. But those each block inside those 4 bytes of space have their own unique addresses defined by the machine. So if we try to have a look behind the scenes to the address, we will see some sort of number like that. So let's have a look. Let's erase this off, or let's just change this to printf function. Let's bring in the command prompt. We have to run the program. Okay. Uh, let's comment this out.